I have a question. And the question is this. Will the internet evolution inhibit the internet itself? And contrary to all the other speakers today, I will talk about the internet as an infrastructure, as the network of networks, the networks that enable people to experience what they usually call the internet, the thing that the previous talks were about. And I, in my heart of hearts, believe what Peter just said in his introduction, namely, the internet is the best invention ever. What the internet is, you know, technical infrastructure, network of networks, but we've looked at it and we've characterized its critical properties. And we did that because we want to understand the evolution of the internet. Our policy proposals and technical proposals moving the internet away from, you know, those critical properties or more towards those critical properties. If you lose those critical properties, you've lost the internet. So it's a tool set we call the internet way of networking. And it's characterized by 5 critical properties for which we have developed icons, and I even don't know which icon belongs to which critical property, so that's not the issue. Those are an accessible infrastructure with a common protocol. Accessible infrastructure means that if you are a new network, you can connect to the internet and become part of it. And that's possible because there is a common protocol, the protocol that we call IP. Now, if you think a little bit about it, you know that that critical property is already not met because there are two forms of IP, IPv4 and IPv6. Second property, it's an open architecture of interoperable and reusable building blocks. It's not one big design, no, it's small pieces that people constantly bundle together, and that makes the internet evolve. And that's what my question is about, actually. It has a decentralized management and a distributed routing system. There's no central authority that says this is how we manage the internet. So regulation is something that threatens that particular aspect. And I don't have to tell you about the distributed routing system because you all manage one of these pieces. No. And you do that according to your own rules. My network, my rules, so to speak. Fourth critical property, common global identifiers. The internet works because we have some commonality. If I type in a domain name here in the Netherlands, I know I end up at a property. If you type that same entity somewhere in, say, Bangladesh, you end up at the same property, modulo some traffic engineering and so on. Fifth property, also very important, is it's technology neutral, and it's a general purpose network. And I think that is one of the tensions that we currently see that the question that I'm asking is about. The classic way of looking at the network is sort of this picture, you know, network of networks with at one side a server and at the other side a client. A client-server network, and you look at it. And of course, this is a very classic way of looking at the internet. The internet doesn't look like that anymore. But it does embody something that was a design property when the internet was designed, namely the end-to-end principle. That was an argument by Jerry Saltzer in 1984, who said basically, you know, if you have complexity, it's better to put that complexity at the edges of the system rather in the middle, because the cost of putting complexity in the middle of a complex system outweighs its benefits. Very, you know, system engineering type of approach. But the internet doesn't look like that anymore. The internet now has all kinds of intelligence in its core, so to speak. It doesn't look like that Saltzer ideal, so to speak. It looks more like this. And I would say, who cares? Oh, the internet evolves. That's one of its properties. Also, technically, it evolves. And if there is user demand for that evolution, then that's okay. And that user demand, of course, is there. It's called edge computing. People are bringing computing resources closer and closer to the user, usually for benefits of performance, essentially. But that opens a bunch of questions. I think most of you in this room have read the works by Jeff Houston. If not, Google for Death of Transit. That's an article he wrote a couple of years ago. And he makes the argument that if things move closer to the edge, applications move closer to the edge, what's the value of transit? If everything is served locally, why would you invest in transit? So why would you invest in that bigger argument, in that bigger internet? Other sign of this is that you have slicing in the 5G architecture. The idea that you have a specific sort of virtual network that is spawned off from the regular traffic and is handled locally, perhaps even in a container near a mast. And if you look at the 2030 vision, that was the future 2030 vision, that was developed in the ITU a couple of years ago, and that was affiliated with new IP, a Huawei proposal that met a lot of pushback. What you see there is also a lot of applications that basically, have very high demands on the network. And the Huawei response was, well, in order to serve those, we need a new type of IP. We need a new internet. We need a new underlying network technology. Ofcom wrote about this. Wrote about the types of applications that are around, that drive this evolution. And you don't have to look at this, you don't have to interpret this graph, but I'll be using this graph a couple of times. And this is basically latency going from about 100 seconds to 1 millisecond and 100 microseconds. And bandwidth going from 10 bits per second to approximately 1 gigabit per second. And what they did is they basically projected types of applications in this field. And this is a reasonable type of projection. On the right side, very specific applications. On the left side, sort of types of applications. Gaming, low latency, high bandwidth, virtual reality. That's where Meta lives. That's the metaverse for us. Haptic can go anywhere from probably somewhat lower bandwidth use, but very high latency. And of course, we all know physics, so we know that 1 millisecond, that's about 200 kilometers. In order to be able to do that, you need to be at 200 kilometers. In order to do this, you need to be at 20 kilometers. So that pushes this image, this movement, the fact that we're moving into these applications means that we're moving towards the edge. And what does that mean for the internet? Well, let's have a look at how the internet evolved. And I made up this evolution, so to speak. So this is not a scientific or historical view, but to give you a little bit of a feel of how we got here. The classic internet, that picture that I showed in the first time, a big cloud, servers at the edges, client at the edges. I would say that's the internet of the 90s. Mostly a network of networks with a few servers and clients that can talk to each other. And traffic would typically flow around the Earth. You would connect a server in the US. There you go, it's a few hundred milliseconds. That is what I call classic internet. That classic internet still exists today. If you have a new innovation and you're a small player, you probably rent some infrastructure somewhere. You put up your data, your server, and you hope that people will draw to you. You might still be far away from the customer edge. The next phase in that evolution, this is like the early 2000s, is the rise of the cache. This is where players like Akamai got into play. I remember I was working at RIPE NCC, and they were still at NICEF at the time, where the AMS-IX started. And you saw Akamai people coming in with disks, physical disks, to replace the caches, because that was cheaper than using transit to fill them. What you also see in that time is that people started to do DNS, Anycast, and dynamic DNS. That sort of served the basis for the next evolution of this. That's the tens, the last decade. This is where you got the concentration of the data centers, where that was enabled by virtual machines, by DevOps, by containerizing stuff, by basically having bare iron and making sure you could orchestrate all kinds of services on top of that. You also see the rise of private backhaul. Companies like Google and Facebook buying fibers. And you see a denser interconnect. This is really the time where you see all the IXs exploding across the world. You see, everywhere where you look, you see IXs rising. I call this the hybrid internet, so to speak. These two pictures. You have sort of you get a sort of a closed type of data center, like the one, say, in the Flevo polder, or you get a regional type of data center. I think that we're now sort of in a time which I call the rise of the slice. Nice rhyme. But this is when, different types of applications that get to the user more quickly. Gaming, video, and we saw this during the COVID pandemic. The network could basically deliver. And in this picture, you get the 5G promise of slices. And the framework of the Future Group 2030 looks at applications that you can basically only serve when very close to the user. I call this the telco model, because I think that this is a place where the telco, who is the closest to the user, has a lot of buying and selling power, so to speak. They can say, okay, you get a slice in our container, and we serve that to the user in a sort of bundled as a bundled service. So this might evolve into users not buying general IP, but buying their gaming connection directly from their access provider. That is my fear if it comes to the evolution of the internet, because then we get a telco model. Where will the investments go? I have interpolated those two pictures that you saw a minute ago from the Ofcom paper on this. These are typical distances, 100 meters, 10 kilometers, 1,000 kilometers. And just to get a little bit of a feeling of where these applications are. I think that most of the applications we can still do with what I call the hybrid internet, with regional data centers, or actually almost closed data centers. You can do virtual reality with a data center in the Flevo polder, or maybe even in Frankfurt. But you cannot do it anymore when your data center is, say, in the south of France. So it needs to be relatively close. For haptic and other types of applications, you really have to be very close to the user. But where is that edge? At what point will we make the transition? And what does that mean for the networks of networks? What does that mean for the internet itself? It's a bunch of questions for which I don't have the answers. So this is sort of the picture that I've shown a minute ago, and now this is where I need to look at what I wanted to say here. Yeah, what makes innovations move? As I said, you can, in the classic model, you could host a service, and you can still do that. I can still build an application as a kid in my attic, serve that on a local service. And when it grows, you know, I make use of the cloud. I buy Amazon web servers or virtual machines across the world. I take the, you know, I use Cloudflare and I scale. This is the beauty of the internet today. You can scale like mad because you can just buy virtual machines all over the place. And the DNS acts as a rendezvous. It's beautiful. So that innovation might still continue to work. And there is a value of having a global internet for, at least for the innovators. What if you are developing in the telco regime? What if you started off like a slice between a handset and a server in a container? Can you go back, or are you stuck in that model? I don't know. So there's a question about what makes things turn around. I think there have been examples of IoT platforms that started in the telco sphere and were then sort of opened up. But I don't know of many. So this is sort of my question, in essence. Suppose that you have an architecture that is the telco architecture that is prevalent, where the important services, the things that users use on a daily basis, their video, their games, all lives in data centers that are close to the mast, so a container. What does that mean for the rest of the internet? What does that mean for innovation? Access to a container is going to be damn expensive. So that's only for a few happy few. That's the consolidated parties of today. And what will be the investment in the rest of the internet? I think there will always be a case for the internet because you need to provision that type of stuff. And I think that there will be a long tail of applications. And I don't even think that that might be threatening. I think there will be a coexistence of these two models. But what the balance will be between those coexistence models, I do not know. And that is, in fact, the question that I have of you. You are all working, from your perspective, somewhere in these clouds. If you close your eyes and you think about that model, what do you think does that mean for you? And with that question, I'm going to leave the mic to the audience. Thank you.
Brilliant. Okay, we've already got a question. Do you mind just putting your hand a little bit higher in the air so you can see? There you go.
You're speaking about the last phase, is the telco phase. Is that not something already past? Because what you see is the hyperscalers offering already edge computing on Outpost or Azure Stack, including a 5G network and private network. So is it really the telco space? Or is it already moving towards enterprises, local communities like airports or cities who can buy edge computing, including your network?
I think at this moment that you don't see those bundled type of offers, really. As a zero rating, perhaps. No, let me answer your question. Yes, I think we entered that space. I think this is the 20s. Huh? We're entering that space slowly. So as I said, there will be a coexistence of those two spaces. But the question therefore is, what does that mean for the internet as a network of networks, as an enabling technology for a lot of good? If everything gets very tightly bundled, services and network, and the networks that deliver those services, that to me is the telco model. It doesn't really mean that the incumbent telco delivers that service, but if Google does the same, that's to me a telco model too, and I don't think that's the idea of the internet. So that's my question. And I don't have an answer to where this leads. That's why I'm here asking it.
Any more questions for Olaf?
Or maybe answers or ideas.
Well, I don't have an answer. But I do have a question. I was curious, and it's maybe not quite related to that, but just watching you talk, and I'm curious to know, is the internet meeting applications' needs today? Or is it holding it back? Or do you think it's the duty of those developing the applications to also take some responsibility for the needs that they're creating that may or may not be already in place? If you're with me.
Is the internet delivering what it needs? I think it was Jonathan Zittrain that said the internet only just works. Basically, the argument there is that the internet always delivers what the market needs just enough. It's never in front of it. It's just meeting the demands. And I think COVID was an excellent demonstration of the internet meeting the needs. But if you look at that Ofcom paper, or that Ofcom graph, or the Future Group 2030, then there are a couple of use cases where they say we need new types of applications, where I am pretty sure that they're so far in the what is it, right-hand, upper right-hand corner, that the internet just cannot deliver, because you need to be 20 kilometers away, and you need to shove 2 gigs of data down a pipe. And I think, you know, this is your factory floor with robotic real-time machines. I don't think that needs to be an internet application. That can very well be a different type application, and the internet doesn't have to develop that. Or at least the internet as a network of networks. Anybody here who offers internet services might be willing to offer that.
Yeah, because there's something to add on to that I was thinking. As you said, the pandemic also got a lot of people working remotely, and the design that you're talking about almost seems to necessitate people getting closer together, so that's easier for the operators to put something down. I mean, I'm from Australia. If I want to go live in the outback, I'm definitely not more than 2,000 kilometres from one of these co-locations you're talking about. So do I need to move to a city to be able to do what I want to do?
Stepping back a little bit, this talk, that's an important point that you bring up, is a very Western perspective. It's the perspective of the place where internet is. The density of data centers here is incredibly high. There are places in the world where there is not a data center for thousands of kilometers. So this is a very Western talk. The evolution that I described here will first take place in the West. And the effect of it, if it is the case that all the investments go into the telco model and not into the internet model, that will make an even bigger digital divide. Because if the investments are not in the internet, then all the people who rely on the global connectivity of the internet will not benefit from it. So I think there are a lot of ways to look at this evolution, but I think it's important to track.